All right, we got to do parabolas today. Come on. Okay. So we're going to do a bunch of vocab. We're going to draw a picture to the side, and then we're going to get started. So, parabola is a set of points in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. All right, let's do a few more definitions and then we'll draw it. So, the vertex is the point halfway between the focus and the directrix. The focus is a point inside the parabola. The axis of symmetry is a line through the focus and the vertex, and it's perpendicular to the directrix. The directrix is a fixed line. It can be horizontal or vertical, as can the axis of symmetry. The parabola opens away from it, and it's perpendicular to the axis of symmetry. We're going to do one more and then we'll draw the picture. P, okay, is the distance from the focus to the vertex and the vertex to the directrix. Okay, so let's draw a picture. Pretend that this is like, I didn't really want to do this. Don't draw that. Don't draw that. You already did? Okay. Don't draw it. Costco stopped selling whiteout. I don't know what I'm going to do. Okay, so you got to draw a parabola. So let's just draw a parabola pointed upward. Okay, now hopefully you remember, way back to algebra, what some of these terms are. And then remember last year you learned all this, so this should all seem somewhat familiar. Remember the vertex is, that max or min point on the parabola. The parabola could point up, down, left, or right. All right. Remember it's where you can fold it over on itself. You know what the vertex is, okay? Now, the focus is inside of the parabola. Okay, now how we mark it, it's got to be on the axis of symmetry. Remember the axis of symmetry was, again, that line of symmetry. You could fold a parabola over on itself, so this is where I wanted to draw that in. Okay, so here's our axis of symmetry. In this case, it would be like an x equals equation, right, because it's a vertical line. And then somewhere in that parabola lies the focus. And the focus usually gets marked with like an asterisk. Okay, so here's the focus. Now, this distance from the focus to the vertex is that distance of P. Okay. Now, whatever that distance is, the directrix has to be that distance of P away from the vertex. The directrix is another line. It has to be perpendicular to the axis of symmetry. So that means if the axis of symmetry is vertical, then the directrix has to be horizontal. They have to be the opposite of each other in order to be perpendicular. And it has to be this distance away. So kind of estimate that distance, and then there's your directrix. So in this case, our directrix would be a y equals equation because it's a horizontal line there. This also is a distance of P. The directrix and the axis of symmetry have to be perpendicular to one another. That's why one's vertical and one's horizontal. Okay. So far, so good? We have more terms. Okay, so let's talk about, let's do it this way. Focal chord. So a focal chord is a line segment passing through the focus, having endpoints on the parabola. Okay, like, so for example, here's our line segment. It has to go through the focus, and this, for example, is a focal chord. Okay, but now there's a special type of focal chord. If it's perpendicular to the axis of symmetry. Then it's called the lattice rectum, and I don't know why it's called that. I think it's torture for math teachers, but we're going to call it the LR because it's much more comfortable to say. Okay, so we're going to call it the LR, and it's importantly equal to 4p. Okay, so this is the whole reason we're going to use this. It's going to help us to write the equation. All right, so you have to remember this. Now, this is the same situation. It's still going to go through the focus. It's going to touch both sides of the parabola, but now it has a special property of being perpendicular to the axis of symmetry. So these are perpendicular. So this is the LR, or the lattice rectum. Okay? Stupid. So far, so good? You want to see the equations now? Of course you do. Okay, so the standard form of the equation of a parabola. Now there's actually 4 of them. Okay, and you have to memorize these, remember. So x minus h squared equals plus or minus 4p times y minus k. Or y minus k squared equals plus or minus 4p times x minus h. Okay, so just like when we were doing like the equation of a circle and you had HK and HK was the center, HK is the vertex, all right? So maybe make yourself a note there if you didn't recognize that. The vertex is HK in this situation. Okay, so when you have an x squared, what do you think that does? Now remember, it can point up, down, left, or right. What do you think it does? X squared. Y equals x squared. Think about the parent function. What does it look like? Points up, right? So anytime you have an x squared term, you're either going to point up or point down. How do you know if it points up? It's positive. So it's got to be the plus 4p. If it points down, then it's got to be the minus 4p. Okay? If you have a y squared term, it has to point left or right. So think about how you could kind of determine that. If it points right, it has a positive 4p. If it points left, then it has a negative 4p. All right, so you have to memorize these formulas. Or equations, I guess you want to say. Okay? All right, we're going to try some stuff now. Any questions on any of the terms or picture or equation? Okay. Example 1. Put the equation in standard form and find the vertex, focus, directrix, and axis of symmetry. Sure. Okay, let's start out with this one. X equals 1/2 y squared. Okay, so what do you notice? It's a y squared. Okay, so we know it's got to be horizontal, right? It's got to point either left or right. Which way does it point? Right, because you have a positive, right? You have a positive a. Now, is this in standard form right now? No, because the y squared term has to be on the left by itself. So it's really easy to manipulate this one, right? Couldn't you just multiply by 2 on both sides? So we would have y squared equals 2x. Okay, so now this is in standard form. We're done with that piece. Okay, now they wanted us to find all this other information. So the vertex, what is the vertex? Remember, it's like minus h and minus k, so you can't see anything, right? Well, isn't this the same thing if you wrote y minus 0 squared equals 2 times x minus 0? Right? This is the same equation, it's just not simplified like the other one. So then that means the vertex is at 0, 0. Now I'll warn you, when it's a y squared term, you know, we read from left to right. So when you go to find the vertex, you got to pay attention and make sure you're choosing the x value for h and the y value for k. All right, so just be careful of that when it's a y squared. Think about what's going on now visually. So we have this parabola. It has a vertex at 0, 0, and it points to the right. So I know so far it looks something like this. I'm just going to do a quick sketch. Okay, so I know it looks like this, but I got to find these other pieces of information. So I have to find the focus, the directrix, and the axis of symmetry. Now the axis of symmetry I can find right now. Right? It's got to be the halfway point that the parabola folds over on itself. It's got to go through the vertex. So where is it? Careful, it's horizontal. Y equals 0. Any horizontal line is y equals. So it's y equals 0. When you write the axis of symmetry, it's an equation of a line. So make sure you write it as an equation of a line. Y equals or x equals. How am I going to find the focus and the directrix? What do you have to know? P. So now think about how you can find P. See that 2? Isn't that 2 like 4p in our situation? Right? So whatever this value is being multiplied, by that term, that x term in this case, we can set equal to 4p, because that has to be equal to that. So I'm going to set it equal to a positive 4p, because this number is positive. If it was negative, I would set it equal to a negative. Now think about why. So when I solve, I get p equals a half. P is a distance. Can p ever be negative? No, so if you get a negative answer, it just means you chose the wrong one to set it equal to. So just take the absolute value of it. Okay? It's got to be positive. It represents a distance. So P is the distance from the vertex to the focus, which has to be inside the parabola, and from the vertex to the directrix, which is outside of the parabola. So where is the focus? Yeah, 1/2 comma 0. It's an ordered pair. It's a point inside of the parabola. We have to move p distance away from the vertex. The directrix has to go p distance away from the parabola. So we're going this way to the left, right? And it's a line, and it has to be perpendicular. So if this was horizontal, now it's got to be vertical. So the directrix is here at x equals -1/2. I'm going to ask you to sketch all of these, both in your homework and on the test. So this would be a fine sketch. All right, enough is labeled. I can clearly see that you knew what was going on there. Are there any questions on this one? Pretty easy. Nothing really to do at the very beginning. Okay, let's do another easy one. X minus 4 squared equals -16 times y plus 1. Okay, so they wanted us to put it in standard form. It's already in standard form, right? So that's done. Now I have to find all that information. So where is the vertex? 4, -1. It's got to be the opposite of what you see, just like the circle center was, the opposite of what was in the parentheses. So this is at 4, -1. Which way does it point? Got to point down, right? It's an x squared, so that makes it either up or down, and it has a -4p, so therefore it points downward. So right away I'm going to go into my sketch. I know the vertex is at 4, -1, and it points down. So it's going to look, something like that. Okay, fine. All right, think about the rest now. So the axis of symmetry is the easy piece to find once you know the vertex. So where is that going to be? X equals 4. It's got to be a vertical line. All right, now I have to find the focus and the directrix. So now I'm focused on finding the value of P. So I have to take this -16 and set it equal to -4p this time. So P equals 4. And now I just have to count. Right? So the focus has to be inside of the parabola. So this was at 4, -1. So I have to count down 4. So now it's going to be at 4, -5. Remember, the directrix is a line. It has to be perpendicular. So if your axis of symmetry was x equals, then the directrix has to be a y equals. You count 4 up. So we're going to be at what? Y equals 3. This is a fine sketch. Okay, now let's do a little bit of a harder one. Y equals 1/3 times x squared minus 4x minus 5. In order to find all this information, you have to have it in standard form. Now, the previous examples really were already in standard form. There wasn't a lot to do. This one, that's not the case. So what do you think we're going to have to do here? Pardon me? The best case scenario is a perfect square trinomial and you can factor it right now. It's not. So then we have to complete the square. Like you're going to have to complete the square every single section in this unit, okay? So the first thing I want to do is I want to get rid of the 3, okay? Well, the 1/3. So to get rid of it, you're going to multiply by 3 on both sides. So now I have 3y equals x squared minus 4x minus 5. Okay? Now what do you want to do? Think about how we completed the square with the circle. We should add over the 5. Yep. So now I have 3y plus 5 equals x squared minus 4x. I don't have to leave a space. It's on the right. Plenty of space. Okay? So I'm just trying to get those x terms alone so I can start completing the square now, creating that perfect square trinomial. So you take half of b. I don't have to factor anything out. I already have a coefficient of 1. I take half of b. That's negative 2. I'm going to square it. So on the right side, I'm adding 4. What do I have to do on the left side? Add 4. Okay, so now I get 3y plus 9 equals, then I can factor this, so x minus 2 squared. Okay, I'm getting closer. I need my square term on the left, so I'm just going to flip-flop the sides. So I'm going to have x minus 2 squared equals, but I have to do something over here with this 3y plus 9. What does it have to look like? You have to factor out that 3. We have to have a coefficient of 1 for both of our variables here. So I'm going to factor out the 3, and I have y plus 3 left over. Okay, so now this is in standard form. So let's think about the visual. You have a parabola. It has to point upward because it's an x squared term and a positive 4p. My vertex is at 2, negative 3. So 2, negative 3, and I know that it points upward. Okay. So where's the axis of symmetry? X equals 2. And then I need to find my directrix and my focus. In order to find those, though, I'm going to have to know P, right? So that's the next step. So what am I going to do to find that? I'm going to take this 3, right, the number on the outside. Do I set it equal to a positive or a negative? Positive because it's positive. So 3 equals 4p, so therefore p equals 3/4. You have to work with fractions in this unit too. You're not going to change that to a decimal. Okay, so now let's find the directrix first. So you got to count a p distance away. It's got to be a horizontal line in this case. So it's going to be y equals what? Think about the vertex. Thinking about counting down 3/4. So it's like negative 3 minus 3/4. So that's going to take us to like negative 15 over 4. Okay. Some of these get really, really messy. The focus then, oh, so I should probably like that. So just like here. Okay. The focus has to go up a distance of 3/4. So I'm going to take that negative 3, I'm going to add 3/4 to it, which is like negative 2 and 1/4, which is like negative 9 over 4. So 2, negative 9 over 4. Okay. Some people are confused out there. Are there questions? Nothing? You want to communicate with me? Okay. All right, so that's how you gather up all the information given in an equation. Now we're going to be given information. We're going to write the equation this time. Yeah, Brett? My picture is not drawn to scale. Yeah, those should be equal. Yeah. Okay, good. Moving on. Okay, we're going to shift gears now. We're going to go kind of like backwards. Write an equation in standard form for the parabola. Okay, so here's the information we're given. It passes through the points 0, 0, 4, 0, and 2, negative 2. Now, remember, you have to decide, is it vertical or horizontal? Is it positive or negative 4p? So those are the types of things you're trying to think about. Where do you think we should start every single time with these? Draw a picture. You have to draw a picture in order to visualize what you've been given, okay? So let's go ahead and do that. It's just a quick sketch. So we know there's the point 0, 0. There's a point 4, 0. And then there's a point 2, negative 2. Think about what we've been given here. Can you see? This is the parabola we have. What are these points 0, 0, and 4, 0? The x-intercepts. What is this point? Why is it the vertex? It's halfway between those intercepts, right? And we can see the symmetry. We can see it fold over onto itself. Okay, so we know the vertex. Is it an x squared or a y squared equation? X squared. And does it point up or down? Up. So we know it's a positive 4p then. So far we know this. X minus 2 squared equals a positive 4p times y plus 2. Right? We plug in our vertex. We know it's a x squared term. We know it's a positive 4p. So now the only thing we have to find is p in the equation. So think about how you could do that. I'll give you a hint. Don't you have two solution points of the parabola? Both of which represent x, y, right? It's a coordinate pair. So couldn't you just substitute in one of those points for x and y and solve for p? Yeah, you could. What is the easiest one to plug in? 0. So let's do that. So 0 minus 2 squared equals 4p times 0 plus 2. So here we get 4 equals 8p. So p equals a half. Okay, but now remember, you have to take that value and substitute it back in. So final answer, x minus 2 squared equals 2 times y plus 2. Questions on that one? All right, next one. Our vertex is at 0, 0, and our focus is 0, negative 3. So we're going to sketch a picture first. So we have a vertex at 0, 0, and then we have the focus at negative 3. Now remember, the focus is inside of the parabola. So which way does the parabola point? Down, because it's got to be inside of it. Okay, so that means it's an x squared term with a negative 4p. So I'm going to plug all that in. So I have x minus 0 squared equals negative 4p times y minus 0. What else do you know? Okay, we know the axis of symmetry. What else? What is this right here? Isn't that P? Right? Isn't it the distance from the vertex to the focus? So what's the distance of P? 3. It's got to be positive, remember, because it represents distance. So here, I'm just going to plug in 3. So final answer, x squared equals negative 12 times y. That was a really easy one. All right, you think about the next one. The vertex is at 1, 4. The directrix is x equals 3. Always, because it's a distance. Try it. Talk to your partner about that. Which way does it point? It's got to point to the left. So like we know that. So you should have started with a y squared term this time. Because the directrix has to be away from the parabola. So the parabola has to open away from it and it can't touch it. So it's got to open to the left there. So now you should know already y minus 4 squared equals, and then x minus 1. Is it a positive or a negative 4p? Is it positive or negative 4p? Negative, because it points to the left. It points to the negatives. So you have a negative 4p. What else do you know? What is this distance right here? This is P, right? You have to know your definitions. So P is from the vertex to the directrix or the vertex to the focus. So that means we know that P has to be 2. So plug it in. This would be considered an easy one again. Okay, these last two are really easy because you've been given P and the vertex. There's really nothing to figure out, just the direction. Okay? We have 2 more left. We got to keep going. Stay strong. So boring. All right, D. The focus is at negative 1, negative 3. The directrix is at y equals 1. Bless you. Okay, let's sketch it. So 1, negative 3. I'm sorry, negative 1, negative 3. So remember, the focus is in the parabola. Then I have this directrix, and it's at y equals 1. And it's a horizontal line. And the parabola has to open away from the directrix. So where does the parabola point? Down. So that means it's an x squared with a negative 4p. Now think about what else we know. Think about the axis of symmetry. The axis of symmetry has to be perpendicular and it has to go through the focus, right? Where does the vertex have to lie? Okay, a negative 1 for sure, right? Because it has to lie on the axis of symmetry. Doesn't it have to be halfway between this distance, right? So you're going from 1 to negative 3. So you have a distance of 4, so where is the vertex at? Negative 1, negative 1. So I know it's x plus 1 squared equals a negative 4p times y plus 1. What is p? 2. Because it has to be half of that distance. Plug it in. This one would be considered an easy one. Notice my sketch doesn't even have a parabola on it. I really don't care about that. I'm just trying to kind of visualize what I got going on, what pieces of information I have. All right, this last one is a little trickier. So the vertex is at 3, 5. It has a vertical directrix. The LR is 12. What do we know? P equals 3. How come? Because the LR equals 4P. So 4P equals 12. So therefore we know P has to be 3. Okay? Good. Let's sketch what we have so far then. We have a vertex at 3, 5. And I have a vertical directrix. And I have a distance of P away from the vertex. So is this parabola an x squared or a y squared? Why? Because if I have a vertical directrix, it's got to open away from it. So it's going to open to the left or to the right. Which way does it open? To the right? So like this? So like my directrix is here? How do you know? Do you? Can you say that for sure? Devin? P is positive. Well, P is always positive. P is a distance. But I don't know 4P is positive. I know that the LR is equal to 4P, but I don't know that in this situation 4P is positive. Oh, what? It's both. Couldn't it be either one? It could either be opening to the right, or couldn't it open this way? And my directrix be over here? So you not only have one equation, but you have two possible equations in this situation. You can't tell. There's not enough to determine which way. So you have to write two equations. Tricky. Okay, we know it's x squared. No, I'm sorry, y squared. So I know I have y minus 5 squared equals, and in this case it's going to be a plus or a minus 4p times x minus 3. But I know p is 3. So I can just plug that in. So I'm going to have y minus 5 squared equals 12 times x minus 3, or y minus 5 squared equals negative 12 times x minus 3. There's no way to determine in this situation if it points right or left. Okay, so you have to write down both.